It's 4-4. So let's make sure everybody is on this page. Okay, if you have the page, have it out. If you don't have this page because you decided to recycle your book, have a sheet of paper out. Make sure your name is on it because it's going to get turned in, but I'm going to go over each and every problem. Quite a few of these have already been worked out up there on this first problem. This is a contingency table based on hair color and eye color. Looks like we have a total of 60 people. We got brown, blue, hazel, and green, and black, brown, red, blonde as far as the hair. Okay, so probability person has blue eyes. So you look how many blue eyes there are, which are 21, and you have a total of 60. So 21 out of 60. Again, you don't have to reduce any fractions. You don't have to make them decimals at this point. Person has red hair. There are 7 people with red hair out of the whole entire group of 60. Person has green eyes or hazel eyes. So count up the green and the hazel eyes, which there would be 16 total. And there's out of this whole group of 60. A person has blue eyes or blonde hair. Okay, so this one you got to be careful on. You don't want, I'll write this up real quick. Let's see. Person, this is number 4. Person has blue eyes or blonde hair. Okay, this is where you got to be cautious. You're still talking about you have 60 people of the group. Okay, but are there blonde hair, blue-eyed people? Blue-eyed, blonde hair people. Okay, so that particular region, you don't want to count twice. Okay, so you got to be very cautious on that. So if you look at this, I got to get closer to the board because I can't see it because Stirrup's eyes ain't what they should be. All right, so blue eyes or blonde hair. So blue-eyed people, there looks like there's 21 of them. Okay, so that's for blue eyes. As far as blonde hair goes, there's 13 of them. Okay, and then you have 9 that have both blue and blonde. Okay, I don't want to count this 9 twice. So what we have to realize is this 9 is part of this 21, this 9 is part of this 13. So you can just go 21 plus 13 and then subtract 9. If you subtract 9, that means you're not counting the overlap twice. Okay? So 21 plus 13, that's 34 minus 9. 34 minus 9 is 25. So you have a 25 out of 60 probability. Yep, 25 out of 60. And then person has blue eyes and blonde hair. There's 9 people with blonde hair and blue eyes out of the whole 60 as a group. A person has brown eyes and brown hair. The brown hair, brown eyed is 12 out of the 60. And then number 7, I'm going to try and re-explain this in a little different context. Okay, so this says person has brown hair such that, number 7, right? Number 7. Brown hair such that they have brown eyes. Okay. All right, so think about this group. You could probably envision 60 people, double the number of people in this classroom. Agree? So how you look at this situation, and this was easier for me when I heard it a long time ago. Okay, this is going to be your denominator. Okay? So this is how, if you it makes it a little more clear to say it this way. Let's say we had truly 60 people in this room that made up that whole board of people with the eye color and hair color. You still following? Okay, so literally if I said this, okay, those of you who have brown eyes, stay here. The rest of you go out in the hallway. Does that make sense? Okay? You don't physically have to do that. I'm just saying Like if I were to say, okay, we have 60 people here. I realize there's only 30, but if we had 60 here and you mimic this, if I said everyone with brown eyes stay here, everyone else go to the hallway. That means that then I'm going to have only 28 people left in the classroom. Then from there, I'm going to say, okay, how many of the people with brown hair have, or the people left in the room with brown eyes, how many of them have brown hair? So brown hair is here, and then there's going to be 12 people with brown. So I have a 12 out of 28 chance that I would select somebody randomly to get that. And then I'd say, okay, everyone that doesn't have the brown eyes, come back in the classroom. Okay, so if you think about that, you're isolating a group, then trying to find a probability based on that. Number 8. What did I do? Is that a 23? Oh, I looked at the wrong number. 23. Thank you. 23. So that should be a 23. Thank you. I just saw the brown and didn't see the title of the. Thank you for covering me. All right, number 8 says person has hazel eyes such that there's black hair. Okay, so this is the same thing. This is going to become my denominator. So basically, like I have all 60 people back in the classroom. Okay, everyone with black hair stay here. Everyone else go to the hallway. So classroom clears out. Excuse me. So now I should have only 12 people in the classroom. Okay, so now that I have 12 people in the classroom, the people that have black hair is 12. Of that with brown eyes of hazel eyes is 2. So I have a 2 in 12 chance of the people who are still remaining in the classroom with the black hair. I have a 2 out of 12 chance. And again, these are ones where you're looking at the fraction going, can I make it 1/6? Absolutely. Okay, but you don't have to reduce the fractions in statistics. It becomes easier, especially as you progress through statistics, to start leaving it as a dirty fraction. Okay, and then number 9, it says person has red hair such that not brown eyes. Okay, so basically we have all 60 people back in the classroom. Okay, any of you that don't have brown eyes, stay here. If you have brown eyes, go. Okay, and then the people, they go bolting out of the class. So person doesn't have that. So basically, the people that don't have brown eyes, I have eye color, so I have brown, which is 23. So I could go 21 plus 9 plus 7. 21 plus 9 plus 7 is 37. Okay, so that's the number of people that should be still in the classroom. They don't have brown eyes. And then person has red hair. But I have a question. Why did I do that? I got 37 right. Okay, the person has red hair. Okay, so red hair is here. And so, hang on. I think I have an error on mine. Am I number 9? Yes, I am. Why did I go 23 minus 3? Person has red hair. Red hair is 7. I have an error right there. Okay, of the people that I have left in the classroom, I have 37 left in the classroom. Does not have brown eyes. So I'm going to not look at, does not have brown eyes. Brown eyes. Oh, I'm looking at too many pages. I have to annotate on this. All right. So I have the 37 Person does not have brown eyes. So the brown eyes, eye color, we're canceling that out. So we're just keeping this group here, which is my 37. Okay? And then a person has red hair. So red hair, basically I should just count all those up. So 2 plus 1 plus 1. It should have been 4 out of 37. This was a mistake. Okay? And then a person has red hair and a person has brown hair. Well, we're saying you had to pick one of them. You can't have them, half dyed, they're just going natural color. So there's a 0% chance that both people have both red hair and brown hair.
What if they have dyed both?
Well, we're going natural color. We're not doing no dyed colors. All right. Are the outcomes black hair and hazel eyes mutually exclusive? Yes. You can have somebody with black hair and hazel eyes, so they're mutually exclusive. Okay. Are the outcomes black hair and brown hair complementary? No. There's other hair colors that are part of that. Okay. And then calculate the probability. So probability of brown eyes is 28 divided by 60. You go 28 divided by 60 on a calculator. Comes up to 0.467. Multiply that by 100, so you get 46.7%. And then for letter B, did I brown eyes?
Yeah, it should be 20.
Dude. Stirp's making all kinds of errors. So that's 23 out of 27 or out of 60.
Yeah.
Now that math is wrong. I don't have the math. So 23 divided by 60 times 100 would be that answer. And then person has brown eyes such that there's black hair. So the black hair should account for 12 people with black hair. Of that group, 7 out of 12 have brown eyes and black hair. So the probability that I would select somebody at random is 7 out of 12, which would come out to 58.3%. And then what's your answer say about the outcomes of brown eyes and black hair? Okay, so you have a higher percent. You have a 58.3% chance of one way versus a 12 out of 60, which is a 20% chance on the other. Okay, this could show there's independence that's taking place, but it's not guaranteed. All right, questions on that side? Are we good? Yeah. The very last question. Basically, you are saying the probability of people with brown eyes. Probability of brown eyes is 23 out of 60. So 23 out of 60 comes to, wait, I'm off. Did I look at the wrong thing again? What does your answer say about the outcomes of brown eyes? Eye color, brown. 23 out of 60. Oh, dang it, man. So brown eyes is 23 out of 60. Black hair is 12 out of 60. Clear. 23 divided by 60. Yeah, 38.3%. 12 divided by 60 is a different number. This is 20%. Okay, so being that this category is more, it could be pointing to independent events, but we don't know it for sure. Okay, it's a little give you a thought that it might be, but we don't know. All right, flip side. All right. And I didn't work these ones out because I was a bum. Okay. All right. So problem number 1 says the probability we pick somebody with true healthy. So true healthy. Health.
Wouldn't it be 576?
Yeah, I think it's 576, so 57.6. 576 out of 1,000. All right, true status. True status healthy.
No, it's got to be 576.
Well,
Number 2.
so I think what you have to look at, I think you have to look at this number here out of the total. So true healthy status. Healthy.
It's just asking for like all the true status.
Oh, okay. Yeah. All right. Let's just go with that. Cool? I don't like this table, how it's set up. All right. So, my friends, that front side should be somewhat complete. Put your name on that if you don't have the actual sheet. Put your name on the piece of paper you filled out. First and last name, just don't put Jerry or Paul or Eddie. Not worried about the backside. All right, I don't like this one, so we're not going to worry about it. We're not worried about backside. I don't like how it's being worded. I'm being lazy. All right, names on those. Pick somebody in the class who becomes the person who gets to collect those. Get in there, would you? Connor's coming around with the folder. Put yours in there, whether it's the exact piece of paper or the. I didn't like how it's set up, so I'm bailing that ship. All right. So in your notes, turn to 4-5. Start turning to 4-5, please, in your books. Yeah. What page is it? Page what?
90.
99? 99.
I'm not seeing it.
There it is.
Wait, Mr. Sturb, I turned in the wrong thing.
Oh.
I don't even know what I turned in.
Connor, here's one more. There was one that was incorrectly turned in. Well, I guess we'll figure it out later. Did everyone give something to Connor that goes in the folder? I'll get these back to you tomorrow.
Do I get extra credit?
Extra credit all day long. All right. So we talked about contingency tables. Contingency tables is one way to organize data. Now we're going to talk about a Venn diagram. A Venn diagram, a lot of times if you've ever seen a Venn diagram, you've normally seen it as just two overlapping events, okay? But Venn diagrams could honestly be this. They could be this. And they get, actually, when a Venn diagram gets like beyond a certain amount, they start making Venn diagrams as like overlapping L's. And let's just pretend Stirrup can draw really good. So Venn diagrams should start looking like that as well. It's just when you have more and more and more events. Okay? If you have two events that are like that, there's no overlap. That means that both events can't take place. But we're gonna go pretty simple. And the nice thing is, you guys get to choose because you have me as the first time I'm teaching stats. Do you guys want to have a quiz on statistics, or should we just move to the new book because this is the very last stuff? All right, I heard it. Quiz it is. All right, there we go. Yeah, I heard the first words. I'm just kidding. We won't do quiz. So what we'll do is tomorrow we'll have to send a couple of you, or maybe I'll go over in the morning and get the books for the next unit. Yeah, this is the last of the stuff. All right. So this all right, this is on what, page 99? Is that what we decided? All right. So this Venn diagram talks about you have a total of 24 students. It says the Venn diagram shows the number of students interested in music, drama, both, or neither. It's important to see that there's 24 students that are interested in drama. Okay? So how did they say that 24 students are interested in drama based on our screen? What do you think? Yeah, it's the 9 plus 15. It just happens to be that 15 of those kids also like music. And then they'd say, is it possible to see it's important to see that 24 students are interested in drama, 22 are interested in music. So if you have 22 interested in music, that becomes the 15 plus 7, which is 22. This one was what, 24? And then you have 15 like both, and there are 12 that don't like either. Okay. So do those numbers make sense how they came about? It might have an overlap of people. I'm not sure about the 12 who don't like drama and music. I like music that has drama as part of it. That's why I liked listening to Motley Crue and Kiss, because those groups had tons of drama. But that's a whole different story. All right. So a couple things to recognize. If I want to count up everybody who is involved in this, I have 9 plus 15 plus 7, 9 plus 15 plus 7, plus the 12. So 9 plus 15 plus 7 plus 12 gives me what? 43. So I have 43 total people that are involved in this survey. The nice thing about a Venn diagram, if it's done correctly, you don't necessarily have, of the 9 people who like drama and then the 15 that like both, I'm not double counting anybody. Okay, so they'll be separated out nicely. Okay, so if you start looking at the Venn diagram and it says, okay, so the probability they like drama, they're saying it's a 24 out of 43 probability. So what you do with that is you take the 9 and the 15 and add it together, and that gives you the 24, and there's 43 total people that are part of it. Okay? If you look at the people that don't like drama, all you have to do on this is just realize, okay, well, there's 43 people total. I'm going to subtract the 24 originals out of the 43, and that's going to give me the 19 out of 43 probability that you like. Excuse me. That
interested in neither, or people are only interested in music.
Yes. Yeah. So the 7 and the 12. All right. Probability they like drama and music. There's 15 that like both, so 15 out of the 43. The probability they like drama or music. Okay. So they like drama or music. This is where a Venn diagram starts getting goofy. Okay, Venn diagram. I have the overlap right here. When I start using the or, you're talking about this region here, you're talking about this region here. You're not talking about the overlap. So that gives you the 9 and 7 out of the total of 43. And so 9, so they like drama or music. Wait. Why? I lost myself on the screen. They like drama or music. Ah,
Would it be just everyone in the circles?
yeah. Okay.
9, 15, and 7.
So, as far as the or, okay. Let me take a step back. When I talk about an and, the and has to be the overlap. When you're talking about an or with the overlap, it's all the regions together. So then I have to add those 15 to it. So 9, 7, and 15 gives me 31 out of 43. I do my math right? I hope. All right. So the big difference, if you have overlap, if you had Venn diagrams that look like this, when you start talking about the and, it just becomes the little overlap portion. That's all it is. When you talk about the or, it's basically all of these events together that you put together. If you have a Venn diagram that's listed like this, there's no overlap. That's going to be, you just count the 2 circles. Okay? Be cautious if you have overlap that your left and your right, your 9 and your 7, or your music and your drama aren't being double counted. Okay, so that's just one thing to kind of watch out for. All right, once again, the denominator, it says once again, the denominator changes with conditional probability. All right. Okay, so it says the probability they like drama such that they like music. So basically what happens in this case, it's like, okay, you have the 43 people in the class total. I'll say, everybody who likes music, stay here. Everyone else who doesn't goes out of the room. So you have a certain amount of people go out of the room. So you basically have 22 people who like music, though there's 15 that like drama as well. So you have a 15 out of 22 probability that takes place. The probability they like music such that they like drama. So then I take 9 and 15, that gives me 24. Say, if you like drama, stay here. The rest of you go out. It just has to be 15 out of the 24 like drama, such being that they like music as well. They like music, but they don't like drama. So the people who like music but don't like drama is the 7 out of the 43 as a total. Okay, or 7 out of 19. So what I'm doing here is I'm taking this 7 here. Glad the vape alarm's going off. I'm feeling safe. For the first time I heard it all year.
Oh, that's what the vape alarm is?
Yeah. Okay, so they like music, but they don't like drama. So if I were to take this situation, say, hey, if you don't like drama, and I think it's a class not being dramatic. If you don't like the drama class, leave. So these people have to leave. And so what do we have left? We have these 7 that like music, these 12 that don't. So that's going to give me 7 out of 12. Okay? Not out of 12. 7 out of 19. So it's going to be 12 plus the 7. So 7 out of 19, that's where that one came from. Okay. You good so far? All right. I just want to briefly show this, but the assignment I'm going to give you is not going to have it. This is a 3-way Venn diagram. So this group here likes Spanish, chemistry, and math, or are taking Spanish, chemistry, and math. These people here are just taking Spanish and chemistry. These 5 people here are taking Spanish and math. These 60 people here are taking chemistry and math. Okay. These 70 are just taking Spanish. These 17 are just taking chemistry. These 85 are just taking math. These 5, I'm not sure what their schedule is, but they're not taking any of them. But I don't want to worry about a three-way thing. I just want to expose you to it. And what I think we could do is, you know what? Let's do this. All right, so friends, being that the homework assignment is a three-way thing, I need a couple of volunteers to go over to the bookstore. We'll go to Bare Necessities. Oh, Mr. Lefebvre.
Mr. L. Mr. L.
All right, you guys pick however many. You give that slip. And then Yeet wants to go too. So go take that to the bookstore, and they will give you that many books.
32.
How much? 4 minutes? Okay, we'll do that tomorrow. Do it tomorrow. Sound good? Hey, so there won't be a homework assignment tonight, so.
So I will say, or if we're gonna do that tomorrow, we do it like earlier class, because I'm leaving class after this period.
Nah, because the homework was just 3-way.
Yeah, no,
Oh.